special. It's a second interview that we're doing on rail, where our objective is to inform and educate the Hawaii public about the project management aspects of rail. And in order for us to do that in this particular segment, we're going to focus in on design. I'd like to welcome In Tae Lee, who's the Deputy Director of Engineering. So welcome and
Thank
aloha.
you. Thank you.
So if you would help us out in terms of the introduction, then tell us a little bit about yourself and your background and what your responsibilities are in the project.
I have about 28 years of experience in highway and transit design. I'm a professional engineer in civil and structural engineering. I have both public and private sector experience. So for the first 17 years of my career, I worked for a DOT, Department of Transportation. Started out as a bridge engineer. So I worked my way up, became a managing engineer. Then I've helped manage the bridge program. And then for HART, I've been with HART for 3 years. And I started out as the lead structural and geotechnical manager, and then became the facilities engineering manager. And in my current position, I'm the Deputy Director of Engineering right now. I've also been on the public sector, where I was in there as a project manager. Then I moved my way up to as a principal, and I managed primarily highway type of projects. Mostly production, doing the work, delivering the product, and so on. I've also been involved in marketing and that kind of stuff too. So I am responsible for the direction of engineering, the design portion of it. Obviously, Dan, our CEO, has the ultimate responsibility, but I am responsible within the policies and the guidelines of engineering. I have the last say, I guess. My boss, the Director of Engineering Construction, is responsible for those elements that's outside of the guidelines and criteria.
Stakeholder is the Hawaii public, people who are going to use the rail. So when you think about the design, what would you say are the most important things that you're looking at in design to meet those user needs?
Well, the system itself provides an alternative to transportation. I mean, because you're not going to have the backups. This is an elevated system, so I think they can rely on a reliable system that'll get you from point A to point B.
I see. Okay, so that's one.
And the design will accommodate for the American Disability Act. For wheelchairs, ADA wheelchairs, you'll be able to take in surfboards, bikes, coolers.
Oh, the surf! You can't leave out the surfboards.
That's right. And I think you can be assured that there'll be safety on the system too. There will be closed circuit TV. There'll be lighting. There'll be patrols going on, so to assure safety in the system.
Okay. How would you describe? Here's where we are in the design phase of rail.
I think we are where we should be as to meet our program schedule.
Okay. So how would you describe the design strategy that's being employed for rail?
Well, there's several factors that we have the strategy for. We want to open the rail for the public in 2017 and final ultimate opening in 2019. So we are designing the first two sections of the alignment, which is the West Oahu Farrington highway section, the first segment from East Kapolei to Aloha Stadium.
Okay.
So, and included in there is the maintenance storage facility. So we have to have that in order to open up for operation.
Mhm.
That's where the trains are stored
Okay.
and maintained. So we have that, and also we have the budget that's coming in. It comes in as the GT tax.
Mhm.
So we can't send out entire project at one time. So we are sending it out in pieces, per se. So we're designing basically from the west end to the east end.
Okay.
The entire 20-mile alignment is separated into 4 sections. First section, or the first opening includes 2 sections of that, from East Kapolei to Aloha Stadium.
Mhm.
And the full opening is from East Kapolei to Ala Moana Center.
Okay. The design, is that contracted out the same way to the same people? Is it design build? Is it design bid build? What's the strategy that's being employed there?
One of the first contracts that went out was a design build project, which was the first segment of the project. And that was to have a tangible product out on constructed so the taxpayers can see what they're paying for.
Okay.
When we did that, we saw a favorable bid. So we wanted to quickly get another project out.
Mhm.
And we decided to do another project as a design build.
Mhm.
Our following project is going to be design bid build.
Design bid
Bid
build.
build.
And the difference between the two is what?
Is the design build is where the contractor is responsible for the design and
Mhm.
to construct. Design bid build is we would procure a final design consultant.
Mhm.
We would have it designed, and then we would procure the construction contractor as a low bid contract.
Is design build and design bid build, are there different levels of control?
There is you lose a little bit of control on the design build because you're contracting it out and they're responsible for the price and everything.
Mhm.
So we provide our contract, as long as they meet the contract, provides us the design that we specified, and they have the flexibility to do that.
What are the elements of the milestones in design?
We divide our design into several NTPs, notice to proceeds.
Okay.
So the first big milestone, the NTP 1A, we call it,
Mhm.
is where we hold a workshop with all the stakeholders. We want to find out what the project constraints are and what opportunities there are.
Mhm.
And we want to inform all the stakeholders so they know what we're doing.
Okay.
Okay, that is the first, and at that time, we also produce a schedule of milestone. What that is you identify all the submittals that they're going to provide,
Mhm.
and you load it with each schedule for each one of those
Okay.
submittals, and you also cost load it. So when they send us an invoice, we
Mhm.
only pay for those milestones that are completed.
I see.
Yes.
I see.
So now we have NTP 1B,
Mhm.
which is basically the preliminary engineering.
Preliminary
Yeah,
engineering.
that
Okay.
is when you're gathering a lot of the information, like for example, field survey, geotechnical borings, potholings to see where the utilities are located.
Mhm.
So you gather up all the information, you do your research on as constructed drawings, then you start doing the preliminary design.
I see. So, okay, so preliminary design, that's 1B.
Sure,
Okay.
1B. And they submit that, we review it, provide comments, and then we have comment disposition meetings to resolve all comments and incorporate those appropriately.
Okay.
Okay. Then we have our NTP2, which is the interim design. That's about 65% design level. And again, we go through the submittal, HART reviews it, we provide comments, and we have the comment disposition meetings
Mhm.
and resolve all comments there.
Okay.
And then we have our NTP3, which is the final design. So they developed the design to approximately about 95% design level.
Another 30% added to the
Yes,
previous.
yes,
Okay.
approximately. And another round of review comments. Once they're all done, then they'll submit their 100% camera-ready plan specs and estimate for our bidding purposes.
So, for those that are not familiar with the design process, what are the end products that come out of design? The way I look at it is I analogize it in physics as mathematics. Okay, that's how you explain what you observed, what you experimented on. So when you look at design, what is the language by which you transmit your final product to the execution phase?
There's a lot of products, but I guess the major one is your plans, specifications, and estimate.
Plans, specifications, and estimates.
These are construction documents, so we can procure a construction contractor, which tells them what to construct, how to, well, we don't tell them how, ways and means, but we tell them what they need to construct.
Yes. Turning to technology, what do you see as a designer in terms of the technological opportunities that you are going to be building into rail?
Well, one of the opportunities that we are implementing is the fully automatic train, the driverless trains. So that is being designed in. Another one is simple thing, but it is the Wi-Fi being available on the trains.
So nobody's going to be suffering from Wi-Fi loss shock.
That's right. I think there's other opportunities there, like fare collection system. I was just at Japan and Thailand, and they have the ticket vending machines, and they have those swipes. You know, they just you put your wallet or purse against this thing, it beeps, they let you in. So I think there's opportunities to do something like that, or use the most advanced technology.
Anywhere I go on the island, anything I see that's metal, a lot of red spots around it. We have the sun beating down, we have the humidity in the air, we have the salt in the air, we have the rains, we have the insect. What assurances are there that the materials that are going into rail as an overall system are going to be able to withstand that for the 30-year life cycle?
I don't think we're doing any testing particularly ourselves, but there has been a lot of tests performed, and there has been rail use in other marine environment near coastlines or on an island, and they've used it successfully in this type of situations. Yes, there may be for like the bridges, there may be a little different maintenance if it was concrete versus steel, but they can both be designed. One may have slightly more maintenance than the other. So our 20-mile system, we did an alternative analysis looking at those physical constraints, the environment and everything, and we determined that to use a concrete structure, not that steel won't work, but we factor in the operations, maintenance costs, and all this, and we decided to use the concrete rather than steel.
I see.
However, we do have steel in certain locations, like at stations, pedestrian bridges, and stuff like that, and they can be used successfully. You just got to maintain it.
If it is novel or somewhat novel, are there any design steps that are added during design to check?
We actually took a team of engineers to the Vancouver system and to learn from their lessons learned or their practice. So we went over there, looked at the system, asked a bunch of questions to try to learn from their lessons learned. So and we would implement that into our design. That's
excellent, because one of my brother's favorite statements, and he's an analyst, says it's not lessons learned, it's unfortunately lessons relearned. We certainly don't want to do that for rail. One of my pet peeves is graffiti. We're going to have all these columns. When you look at it as a designer in terms of trying to preclude all of our columns to being graffitied, is there anything that can be done?
We are spraying all our columns with anti-graffiti sealer up to a level where it can't be accessible.
Could you give us some examples of what you in design are looking at in terms of major systems and then subsystems?
And operationally,
Mhm.
I guess you have the train as a system,
Mm-hmm.
and that's running west to east, east to west corridor, and we're going to have bus systems, subsystems, feeding each stations.
Mm-hmm.
I guess that would be considered as a system and a subsystem.
Certainly,
So,
big ones,
right.
yeah.
And as far as the design is concerned, we have the core systems, which is responsible for the vehicles,
Mhm.
the communications, train control systems and stuff. But that's got to be worked in with the fixed facility, like
Mhm.
the bridge, the stations, and then all that has to be supported by the foundations,
Sure.
and columns and foundations. I guess so. We have those system and subsystems that we have to integrate.
The reason I asked that is exactly for that integration purpose,
Oh.
because since you're doing some that are, in segments, okay, and in
Mhm.
phases,
Mhm.
when I think about change control,
Mhm.
all right, so you've got an overall system concept, a system design, preliminary engineering and all of that occurs,
Mhm.
and now you're into design of a section, changes occur.
Mhm.
How is that then assessed as to whether or not to allow that change or authorize that change?
Mhm.
And then how do you take those changes that are being authorized and make sure that there isn't a ripple effect someplace further down the line or in a different phase that's in a different phase of design?
That's a very good point. We have a couple of things in place. We have a change management process, and then we have the interface management process. And they really work together, just for the situation that you're explaining.
Mm-hmm.
So if we have a change in one of the contracts, as part of the change process, we have to identify all impacts.
Okay.
Meaning you don't just identify this is an increase in, maybe a decrease in cost in that particular contract, but it may increase cost in other areas.
Mm-hmm.
So we have to look at the overall project impacts to any changes that we do.
I see.
And we also check the master project schedule
Mm-hmm.
to if we have to delay this contract for a month, what does it do to the entire project schedule?
Yeah, how does it not cascade, so it doesn't cascade
Exactly.
into a overall
Sure.
dilemma? Yeah.
So we do look at all of those impacts before we make a decision.
Mm-hmm.
And in our interface management plan, we know where the interfaces have to take place.
I see.
If, for example, one designer designs a bridge to point B,
Mhm.
and second designer starts from point B, so
That's an excellent example.
yeah, so they have to share all that information with them,
I
so
see.
they can take it from there.
Who's responsible for the quality management?
So for the design,
Yes.
yeah, the designers are responsible for the quality management, and we do audits to their quality management
Mm-hmm.
to make sure they're performing as they said they will be.
Okay.
And we provide non-compliance reports if we find things.
Mm-hmm.
So they're responsible for it, but we do provide audits to make sure that they're doing their job.
All right, and then as part of the product of the design phase, is there any kind of a quality document that comes out of there that says these are the requirements and these are the metrics that have to be met in your contract and in your meeting the specification?
We have a HART quality management plan.
Mm-hmm.
Each of the final designers are required to develop their own quality management plan that's consistent with ours.
Mm-hmm.
So they will decide, yeah, we're going to design this thing, we're going to have an independent checker, we're going to have an independent reviewer. They identify all of that.
I see.
Then we make sure that they're doing their job, making
Mhm.
sure they're meeting their quality.
That's your audit phase.
That's
Yeah.
correct.
Every project has critical parameters.
Mhm.
All right, so if you were, as you look at you're progressing into design, then what would you identify most critical parameters that you need to take into account in the design?
I mean, interface is probably the most that I'd be concerned about. We are letting each of these contracts at different times, and they all have to line up to interface properly. If one contractor or designer is asking the question, we have to have that other contract in place and designed to a point where they can actually respond to that question. So it's been very challenging to make sure those interface happens. And it's been very challenging to work with the designers, try to accelerate them to respond to those questions, because they may not be as far along as they should be. Yeah, so that has been a challenge. I see that as one of the big challenges and to mitigate.
You mentioned that the ticket purchase machines. So you're assuring us that we're not going to need computer science background in order to be able to get our tickets?
You know, like I said, I went to Japan and Thailand.
Yeah.
I rode the systems there. I was able to figure out all the ticket vending machines, and I was able to ride and get to where I needed to go.
Well, you're better than me, because I couldn't do that for BART in San Francisco. So you think that the facility for people's use is going to be there?
Yes, I believe so.
Okay. So you mentioned that the driverless trains, you went to Vancouver, you saw what they did there. So there's a high level of confidence that in fact that kind of approach can be taken and successfully applied here in Hawaii.
Yes, I believe so.
Okay.
Looking at the system in Vancouver, I actually rode the system, and they had a train, I don't know exactly what frequency, but it appeared like every 4 minutes or something like that. So it was functioning really good. I thought it was.
Well, I'm glad you brought that up, because looking at it then from an operational standpoint, and saying there's a set of benefits that comes from the driverless trains. What do you see as the biggest benefits coming out of having driverless trains?
I think it's better controlled, because it's controlled in the command center at the maintenance storage facilities. I don't think you can run the trains in those frequencies if they weren't automated.
I see. On special occasions, like there's a game at the stadium or something like that, is there enough flexibility in the system to add trains if needed?
Yes, I would think so.
Okay.
I don't know the answer to that, but I'm pretty sure that you can.
Okay. All righty. Well, I'd like to thank you so much.
Thank you.
Sorry for the grilling. It must sound like it's a trial or something, but the designers have to answer all these questions and be responsible for them. And no matter what you do, somebody's going to come back and say, you didn't design this factor into it. So I empathize with your position. Good luck, and thanks again for joining us.
Thank you.
I'd like to thank our audience for joining us today. Hope you find this informative and educational, and I hope that it presents to you a sense that the project management aspects of rail are in great hands, and that we're going to wind up with a design that will meet the specifications and the needs that have been identified for the Hawaii public. Aloha. Thank you.